Now let's go with ABCD parameters. Third one, transmission parameters. Or ABCD parameters. V1, I1 is expressed in terms of V2, I2, but V2 minus I2 we take. This minus sign is taken for our convenience because in two-port network at the receiving end, we generally inject the current in the analysis point of view. But in the actual transmission lines, what's happening? Receiving end, the current is drawn by the load, right? So there is an opposite direction. Just to make it convenient for us in the analysis point of view, we generally take minus I2. Okay, so now here V1 is equal to AV2 minus BI2 equation A. I1 is equal to CV2 minus DI2 B. Okay, what is A? V1 by V2 when I2 is 0. This is open circuit. You know how to make I2 0 already we have discussed in Z parameters. So I2 0. This is called gain, but it's not forward gain, it is a reverse gain. It's not output voltage by input voltage, it is input voltage by output voltage. Therefore, open circuit, reverse voltage gain. Reverse voltage gain. Then another parameter C can be calculated, I1 by V2. Okay, I1 by V2. So what do you get I1 by V2? Open circuit, transfer admittance. Yes or no? This is called transfer admittance because I1 by V2, current by voltage, input current by output voltage, therefore transfer. Current by voltage, admittance. That's it. I don't want to draw the circuit because already we have experienced when I2 is 0. We have already experienced in case of what? Z parameters. Now let us take V2 0. V2 0. So what do you get? Tell me. V2 0. So C already we have calculated, A we calculate, B and D now. So what is B that can be defined here? V1 by minus I2 when V2 is 0. That means it is short circuit. Transfer impedance. D. I1 by I2. I1 by minus I2. I1 by minus I2 when V2 is 0. Short circuit. Okay, reverse current gain. Because I1 by I2, it's not I2 by I1. Understand? Now equivalent. Equivalent of any two-port network in terms of ABCD or transmission parameters. But if you observe that the first equation says V1 is equal to AV2 minus BI2. So I think you understand V1 is equal to some voltage plus some another voltage or minus some other voltage. So sum of these two, that means series combination it suggests. The first equation suggests that go for series combination. But second equation again on the input port side because I1 is equal to. Yes or no? V1 is equal to means this is a voltage, sum of two voltages, I should go for series combination in single loop. But I1 is equal to I1 plus I2. This is I1, this is I1 dash, this is I1 double dash, let us say sum of these two. That means parallel combination. Total current is sum of two currents. We have seen in the Y parameters equivalent circuit or equivalent circuit in terms of Y parameters. So first equation suggests on input port side you go for series combination. Second equation suggests that go for parallel combination on input port side. You understand? How is it really possible both at a time? First equation says input port side you go for series combination like in impedance parameters. Equivalent circuit in terms of impedance parameters. Second equation suggests that go for parallel combination like equivalent circuit in terms of Y parameters. At same pair of terminals, how is it possible to go for both series and parallel? It is not possible. If one side series, the other side parallel, okay. But at one particular pair of terminals, same pair of terminals, how is it possible to go for series and parallel? Therefore, from equation A and equation B, from equation A and equation B, okay, it can be understood that equivalent of any two-port network in terms of ABCD is not possible. I hope all of you agree with me. Is not possible. So this is very, very important. I can construct an equivalent of any two-port network in terms of Z parameters, Y parameters, but not ABCD parameters. Understand all of you? Okay. Now, what about condition for symmetry and reciprocity? You know the condition for symmetry and reciprocity in terms of Z parameters, but you want now in terms of ABCD. That means you have to express ABCD in terms of Z parameters. Okay. So symmetry and reciprocity. For this, ABCD in terms of Z parameters we must calculate. Understand all of you? Okay. This will help you not only in this case, but the same experience will help you in other case also. Because sometimes in the exam he is asking, he will give H parameters, he will ask Z parameters. He will give Y parameters and he will ask ABCD parameters. He will give ABCD parameters and try to calculate H parameters he will ask. So what will you do then? You must know the procedure. There should be a standard procedure. You can't remember all the formulas. If you want to remember the formulas, these many combinations you get. You look at this. Z, Y, transmission, inverse transmission, H, G. Again, Z, Y, transmission, inverse transmission, H, G. How many combinations you get? Anyway, Z in terms of Z is not required, but Z in terms of Y, Z in terms of T, Z in terms of T inverse, Z in terms of H, Z in terms of G. Look at this. Like this, I go for so many combinations. Yes or no? I don't need this, but look at this. 6 and 6, totally 36 combinations. Out of which 6 you remove because Z in terms of Z is not required. Y in terms of Y is not required. Yes or no? But finally 36 minus 6, totally 30 formulas are required. How can you remember all these formulas? Yes or no? Your memory is not sufficient, definitely. So therefore, I give you a standard procedure how to really express one type of parameters in terms of other types of parameters. Look at this all. It's very, very important. Okay. Standard procedure. So whenever you want ABCD in terms of Z, first you write equations of ABCD. What is ABCD equations? V1 is equal to AV1 minus BI2. You call it equation A. I1 is equal to C, this is V2, okay? CV2 minus DI2. You call it B. Understand? Now, you also write the equations of Z parameters. You just keep this aside for a moment. Don't disturb these equations because ABCD in terms of Z, ABCD equations first, don't disturb them. But write Z parameters, then disturb those equations. I'll tell you how. So Z11 I1, Z12 I2, equation 1. V2 is equal to Z21 I1 plus Z22 I2, equation 2. Understand all of you? Okay. Now I manipulate somehow these two equations so that the resulting equations can be comparable with A and B. Then I can easily express A, B, C, D in terms of Z parameters. I hope you understand my intention here. Okay. So therefore, let us look at this, all of you. So if you see the second equation, it is in terms of V2, I1, I2. If you also look at equation B, it is also V2, I2, I1. V2, I1, I2 V2, I1, I2. That means if you rearrange this equation, you can easily compare these two. Yes or no? Now look at this. From equation 2, what do you get here? From equation 2, I want to go with I1, nothing but 1 by Z21 V2 minus Z22 by Z21 I2. Can I call it equation 3? Now equation 3 and B can be compared. Okay. So let us keep it aside. Now if I look at 1 and A, I can't compare because V1 I1 I2, but V1 V2 I2. So if I eliminate this I1 and express in terms of V2 I2, this entire equation will be in terms of what? V1 V2 I2 1. Then I can compare. Therefore 3 in 1. You substitute. Then what will you get here? V1 is equal to Z11 of 1 by Z21 V2 minus Z22 by Z21 I2, okay, plus Z12 I2. Now look at this. Z11 by Z21. Z11 by Z21 V2 minus. Can I take I2 common? Yes, I can. Z21 into Z1, you can take Z11 Z22 by Z21 plus Z12 into I2. If I take I2 common, if I take LCM also, Z11 Z22, I take minus also common, then minus Z12 Z21. So therefore Z11 Z22 minus Z12 Z21 by Z21 into I2. I hope you understand this. This is nothing but del Z only. Therefore V1 is equal to Z1 1 by Z21 V2 minus del Z by Z21 I2. Equation 4. Now comparing equation 4 with A and equation 3 with B, I'll get now A is equal to Z1 1 by Z21, B is equal to del Z by Z21, C is equal to 1 by Z21, okay, C is equal to 1 by Z21, D is equal to Z22 by Z21. You understand all of you? Okay. Now from this, so this is how you express ABCD in terms of Z parameters. Understand all of you? Okay. Well, now if Z11 is equal to Z22, it is clearly visible from this that if Z11 is equal to Z22, I get A is equal to D. A is equal to D. So therefore A is equal to D, because this is condition for symmetry. This is also condition for symmetry. Therefore it is the condition for symmetry in terms of ABCD. If Z12 is equal to Z21, let's see what will happen here. What will I get here? Z12 is equal to Z21. I don't understand anything from this, but if I calculate AD minus BC, look at this. What is AD minus BC? AD, Z11, Z22. Okay, by Z21 square minus BC, del Z by Z21 square. What is del Z? Z11, Z22 minus Z12, Z21. If I substitute there, I'll get Z11, Z22 get cancelled and minus of minus plus will be there. Z12 into Z21 by Z21 square. But already you applied this condition. Z12 is equal to Z21. Yes or no? Okay. So both will get cancelled and it will be 1. So if AD minus BC, okay, AD minus BC is equal to 1, then this is called condition for reciprocity. Condition for reciprocity. Please note down. So we'll go with inverse ABCD parameters like A dash, B dash, C dash, D dash parameters, or else inverse transmission parameters. So you can find the same way, the same logic you can apply, the same condition for reciprocity and symmetry you will get. A dash is equal to D dash, A dash, D dash minus B dash, C dash is equal to 1. You will get definitely the same thing. You please proceed. I already gave you the relation between the variables. Now V2, I2 is equal to A dash, B dash, C dash, D dash is equal to V1 minus I1. You proceed with that. So I don't want to do this now. You can do, it is left to you. Okay. But now I go with hybrid parameters. Or H parameters. Or H parameters. V1 I2 is equal to H11, H12, H21, H22. This is I1 V2. V1 is equal to H11 I1 plus H12 V2. Equation A. I2 is equal to H21 I1 plus H22 V2. Equation B. You understand? Okay. So how do you define it now? The parameters can be defined. H11 is equal to V1 by I1 when V2 is 0. You call it short circuit input impedance. H21, you will get H21. Okay, because when V2 is 0, you will get two parameters. One is H11, the other is H21. What do you get here? I2 by I1. Yes or no? When V2 is 0, you will get H21. That is I2 by I1. Short circuit input impedance, first one. The other one is short circuit current gain, forward current gain or current gain. Now when I1 is 0, that means open circuit. You will get H12, right? This one. That is V1 by V2 under the condition I1 0. Already mentioned. That is open circuit reverse voltage gain. H22 is equal to, what is H22? I2 by V2. I2 by V2 when I1 is 0. Open circuit, okay, open circuit, output admittance, open circuit, output admittance. You understand all of it? Well, so the equivalent circuit, is it possible now? Yes, it is possible in this case because the first equation suggests that apply KVL or series combination on input port side. The second equation suggests that go for parallel combination or KCL you apply on the output port side. So one is an input port, the other is output port side. It is quite possible. You have seen in ABCD parameters, it was not the same case. Yes or no? But here it is possible. Equivalent of any two-port network in terms of Z parameters. Oh, I'm sorry, equivalent in terms of H parameters. Okay, so what is suggesting here? V1 is equal to H11 I1. So this is 1 dash. This is plus minus V1. This is I1. So I get now H11. Okay, or else I take Z1, H11 here. Okay, H11. Now I have a voltage source here. plus minus H12 V2. V2 is a variable on the other port. Now you see it's a parallel combination on the second port. What is this value? H21 I1, and this is H22, and you got voltage V2, and this is I2. So V2 into H22 will give you H22 V2. This is one current, this is another current. Sum of these two currents will give you I2, and this will give you H11 I1. So what will you get here? Okay, this is what the two-port network now. Yes or no? The equivalent of any two-port network. You give me T model, you give me pi model, lattice model, any model you give me, I can replace it by this particular equivalent using H parameters. Okay, so this is equivalent of any two-port network in terms of H parameters. Now, the most importantly, condition for symmetry and reciprocity. For that, we express H parameters in terms of Z parameters. We just express H parameters in terms of Z parameters. Okay, H parameters in terms of Z parameters. From the equation A, first let us write H parameters equations. You already have A and B. Now you write another parameters. What is that? Z parameters. So V1 is equal to Z11 I1 plus Z12 I2, equation 1. V2 is equal to Z21 I1 plus Z22 I2, equation 2. Okay. Now let us try to express the H parameters in terms of Z parameters. Therefore, don't change these equations, but change these equations. Now, if you compare 2 and B, you will understand I2 I1 V2, I2 I1 V2. Then if I just rearrange from 2, I2 is equal to what will I get here? Minus Z21 by Z22 I1 plus 1 by Z22 of V2, equation 3. If you substitute this 3 in 1, then the resulting equation can be comparable with A, equation A. So tell me what is that you get. V1 is equal to Z11 I1 plus Z12. What is this I2? Minus Z21 by Z22 I1 plus 1 by Z22 V2. Now you will get, what do you get here? If you take common, what do you get here? Del Z, yes or no? Z11 Z22 minus Z12 Z21. That means del Z by Z22 into I1 plus Z12 by Z22 V2. This is called equation 4. Now equation 4 with A and equation 3 with B, you will get H11 is equal to del Z by Z22. Okay. H12 is equal to Z12 by Z22. H21 is equal to minus Z21 by Z22. H22 is equal to 1 by Z22. So from this, if Z11 is equal to Z22, because this is what condition for symmetry. Now if you apply this, let us see. If you apply this, you won't understand anything directly from this, but if you calculate del H, what is del H? H11, H22 minus H12 H21. This is actually called del H, determinant of H matrix. Okay, what do you get here? H11 H22. That means del Z by Z22 square minus H12 H21, H12 H21, minus of minus. Okay, you will get plus Z12 Z21, Z12 Z21 by Z22 square. So what will get from this? Z11 Z22 by Z22 square. Already you mentioned Z11 is equal to Z22. This condition you already mentioned. So therefore will get cancelled. Finally you got 1. Therefore del H is equal to 1. This is called condition for symmetry. Agree all of you? If Z12 is equal to Z21, this you understand from this. Look at this. H12 is equal to H21, but only minus sign is the difference, right? If Z12 is equal to Z21, then H12 is equal to minus H21. Therefore, H12 is equal to minus H21. This is called condition for reciprocity. This is called condition for reciprocity. Okay. So students, I guess you understand how we derive condition for symmetry and reciprocity, how to construct the equivalent of any two-port network in terms of H, in terms of Z, in terms of Y. Please take down this quickly. Now let us see the inverse H parameter that you can work out. Okay, G parameters or inverse H parameters or inverse hybrid parameters. This you can work out. Okay, similar way. I gave you all the relations. Okay, but now let us look at another important part of it: interconnection of two-port networks. Interconnection of two-port networks. There are different ways to interconnect the two-port networks. The first type of two-port network is cascade combination. What do you mean by cascade combination? If there are two-port networks connected in cascade, that means the output of the first two-port network is given as an input to the second two-port network. Similarly, there are three. Second two-port network output is given as an input to the third two-port network. Like that, it will be taken. Usually in the cascade combination, okay, we can analyze the cascade combination of two-port networks easily using ABCD parameters or transmission parameters. Okay, transmission parameters or ABCD parameters. Second one is series combination. What do you mean by series combination? Two elements are said to be in series if the current flowing through the two elements is same. And if you give some voltage, the voltage will be divided. Yes or no, all of you, okay? Two-port networks are connected in series or said to be in series if both the two-port networks are having same current, both sides, input port side as well as output port side. Okay, whatever the current is getting into first two-port network, the same current should get into what? Second two-port network on the input port side. Similarly, in the output port side also, the same thing should happen. Then only both are said to be in series. That means input side series, output side is also series, then both are said to be in series. Okay, series combination means what? Current must be same. This we already know this, right? So therefore, here this means both input and output side series combination, and it is easy to analyze using Z parameters. Generally, we take the help of Z parameters to analyze such combinations. Similarly, parallel combination. What do you mean by parallel combination? What do you mean by parallel combination? Again, both input port and both input side and output port side. Parallel combination. What do you mean by parallel combination? What do you mean by parallel combination? The voltage must be same. The voltage across the first port network on the input port side and voltage across the first port terminals of the second two port network, if both are same, and that's not enough, again on the output port side also, if both the networks are having same voltages, then they are said to be in parallel. But usually Y parameters are more suitable to deal with, more convenient. Then hybrid combination. What do you mean by hybrid? There are two types of hybrid you can see. Hybrid combination of two port networks. Hybrid combination of two port networks. What do you mean by hybrid combination of two port networks? Input port series and output port parallel, or else second type. This is the first combination. The second combination is that input port parallel and the output port series. Understand all of you? Okay. Now here these parameters are dealt with, okay, H parameters. This particular combination is dealt with H parameters. This particular combination is dealt with G parameters. So G parameters are more suitable if input is parallel, output is series, and output is series. And H parameters are more suitable when input is series and output side is parallel. I hope you understand there are four different types. Again, in the fourth type, you have two different types. So interconnection of two port networks. Cascade, easy to deal with the combination using T transmission parameters. Series combination by Z parameters. Parallel combination by Y parameters. Hybrid combination by H and G parameters. Okay. So let's start with the first one, cascade combination. Two two-port networks are said to be in cascade. This is TX, first network, X network. TY. Okay. Output of the first two-port network is given as an input to the second two-port network. This is plus minus V1x and I1x. V2x and I2x. V1y and I1y. V2y and I2y. Clear all of you? Okay, well. Now overall two-port network is V2, this is I2. The overall two-port network input port side, this is V1 and this is I1. This is 1, 1 dash. Clear all of you? Okay. Now, this is what the overall two-port network. and replaced by a single two-port network. So now interconnection of two-port networks, this combination can be reduced to be one single two-port network, okay, whose variables are V1, I1 and V2, I2. Understand all of you, okay? Now what is the relation between the variables in case of first? What do you get here? V1x. So let us see first of all the relations. The relations you can see here. V1 is equal to V1x. I1 is equal to I1x. Yes or no? Is one combination. You can see I1y is equal to minus I2x. Opposite directions. V1y is equal to V2x. Say this is second combination. You can see there V2 is equal to V2y and I2 is equal to I2y. This is equation 3. Understand? Now you get V1. You can see here. Now what is actually the relation between V1, I1, V2, I2 of the first network? V1x and I1x will be in terms of Tx, okay, V2x minus I2x. Yes or no, all of you, okay? But you already know that V1x is nothing but V1. I1x is nothing but I1. V2x is nothing but V1y. Minus I2x is nothing but what? I1y. Yes or no, all of you, okay? Then you will get Tx into, what is V1y, I1y? V1y, I1y is equal to Ty into. Okay, this particular part is okay, same as it is, but this part now I am replacing V2y minus I2y. But you already know that. This is V1y, I1y is replaced by this. Now Tx into Ty into, but what is V2y is nothing but V2 only. Minus I2y is nothing but minus I2 only. Therefore V2 minus I2. You understand all of you? Okay. So V1 and minus I1. Therefore you will get V1, I1 will be off. Understand all of you? Okay. You will get Tx in Ty minus I2. This is nothing but the overall T. That means the resulting T will be product of individual T matrices when n number of two-port networks connected in cascade. The resulting T matrix of the overall two-port network is the product of individual T matrices. I hope you understand the point. Okay, so this is what the result when we take the cascade combination. Quickly note down. We can move on to the next series combination and then parallel combination like that. So what do you mean by series combination? Two two-port networks are said to be in series. Zx Zy. I told you already, it is easy to deal with the analysis. It is easy to do the analysis with Z parameters. Okay. So 2, 2 dash, 2, 2 dash, 1, 1 dash, and 1, 1 dash. Now you know that the voltage here is V1x and this is I1x. This is V1y and I1y. V2x and I2x. V2y, and then I2y. Okay. Now, two two-port networks are said to be in series. If, okay, if what? If the current entering into this particular network is same as the current entering into this network. It's very clear that I1x is entering here and also leaving from the same, right? Returning path also, in the return path also same current you will expect. So what is this current I1x, right? If you send the same current here, now the same current flows here, right? Yes or no? The same current comes outside. Similarly, I2x, then I2x, okay? And the same I2x you send here, then you will get the same I2x outside. So finally, these are the two pairs of terminals. These are the two pairs of terminals now. This is 1, 1 dash, and this is 2, 2 dash. Okay? And these are said to be in series, and the overall two-port network is this one, this box. This box represents the overall two-port network. Now I can reduce this two-port network by a single two-port network. Replace it by. The overall two-port network voltage is V1, let us say this is I1. And overall two-port network current is I2, let us say this is V2. So from this we understand certain relations. You can see here, I1x is equal to I1y, yes or no? And V1 is equal to, and also I1, right? I1 is equal to, I1x is equal to I1y. I1, that's it. And another relation is, I2 is equal to, I2x is equal to I2y. Okay, this is one relation. Another one is, V1 is equal to, okay, because it is dividing to apply KVL, then what do you get? V1, V1x, and V1y. So V1x plus V1y. V2 is equal to V2x plus V2y. This is another relation. Now, if you write the equations of the first one, V1x, V2x is equal to Zx, I1x, I2x. And the V1y, V2y is equal to Zy into I1y, I2y. Equation 2. But you already know that I1x is nothing but I1, I2x is nothing but I2, I1y is nothing but I1, I2y is nothing but I2. Yes or no? From this relation only I am writing. So equation 1 plus 2 if you do and take that I1, I2 because they are common, what do you get? V1x plus V1y, you will get what? V1y. Yes or no? V1x plus V1y is nothing but what? V1 only. And the V2x plus V2y is nothing but V2 only. So what do you get here? Zx, okay, of I1, I2 plus Zy of I1, I2. Yes or no? Then this is nothing but what? V1 totally. This is nothing but what? V2. This is V1. So therefore, finally you will get V1, V2 is equal to, you get now Zx plus Zy, I1, right. This is the overall Z. Therefore, overall Z is nothing but Zx plus Zy plus and so on Zn. So what is the overall Z matrix? Is nothing but sum of individual Z matrices. You understand all of it? So like this, you can proceed. Now, please note down quickly. Now let's see third combination, interconnection, parallel. It's always convenient when you deal with y parameters. Two dash. Okay, so what is this? V1 x, this is I1 x. This is V2 x and this is I2 x. I1 y, V1 y, V2 y, I2 y. Okay. So two-port networks are connected in parallel. They are said to be in parallel if the same voltage is appearing across both the two-port networks and both both the input port side and the output port side. Yes or no, all of you? Okay. So let me take something like this, 1 dash. If I add this 1 and this 1 and make it as 1, if I add this 1 dash and make it as 1 dash, 1 dash, plus minus V1, and this is I1. Okay. 2 and then 2 dash and 2 dash. Understand all of you? Okay. So if you see now, V1 is given to first network, V1 is given to second network. V2 is given to second network and first network. Look at this V2, this and this. That means both the networks are experiencing the same voltage on both sides. Both sides in the sense, first port side V1, second port side V2. Yes or no, all of you? Okay. Therefore you can say that both the networks are in parallel combination. Okay. So this is what the overall two-port network, I can say. Overall two-port network. Now you have some relations. What are they? V1 is equal to V1x is equal to V1y. Okay. V2 is equal to V2x is equal to V2y. This is one relation. I1 is equal to I1x plus I1y. Why? It is so. I1 is getting divided. Voltage same, but current divides. Look at this. So this divided current will be, if you apply KCL at this node, I1 is equal to I1x plus I1y. Similarly, you get I2 is equal to I2x plus I2y. This is another relation. Now, if you write the equations, I1x and I2x is equal to yx, V1x, V2x. Equation 1. I1y, I2y is equal to yy into V1y, V2y. Equation 2. If you add these two, 1 plus 2, what will you get? I1x plus I1y, I2x plus I2y is equal to yx, V1x, V2x plus yy, V1y, V2y. Okay. But what is V1y, V2y? This is V1. This is V2. Already we have seen the relation here. Okay. This is V1. This is V2. And this is nothing but what? I1. And this is nothing but what? I2. I1, I2 is equal to, you will get now yx plus yy into V1 and V2. This is nothing but overall y, yes or no? Therefore, the overall y matrix is equal to sum of individual y matrices. So, except for cascade combination, okay, you will get always addition of individual Y matrices to get the resulting matrix, whether it is a hybrid or parallel or series. Only cascade combination you will get product of individual transmission matrices, right? So please note down quickly here.